These are the relative frequencies you should have calculated. Now let's look at how to construct histograms of discrete data. The difference between this and the M&Ms is that the categories on the horizontal axis are numbers. In the candy example, the categories were colors, which were qualitative data. Color represents a quality or characteristic of the candy. So here's our bar graph when we did M&Ms. A histogram is constructed by drawing rectangles for each class of data whose height is the frequency or relative frequency of the class. The width of each rectangle should be the same and they should touch each other. So that's different from a regular bar graph. A histogram is a special kind of bar graph. Draw a frequency and relative frequency histogram for the number of cars per household data. Here's our table with the frequency and the relative frequency. And this is what a frequency histogram would look like. Notice on the bottom we have the number of cars, and then above each number we have the frequency. So the households that had 0 cars are represented in the first bar, the households that had 1 car in the second bar, and so forth. This is the relative frequency, and we can tell that by the title on the vertical axis, and we note that those are decimals. Now we're going to look at organizing continuous data in tables. The difference here is that the categories on the horizontal axis will be intervals of numbers. A good example is grades. B grades would be any grade that is in the interval from 80 to 89, for example. Categories of data are created for continuous data using intervals of numbers called classes. The following data represents the number of persons aged 25 through 64 who are currently work disabled. The lower class limit of a class is the smallest value within the class, while the upper class limit of a class is the largest value within the class. The lower class limit of the first class is 25. The lower class limit of the second class is 35. The upper class limit of the first class is 34. The upper class limit of the second class is 44, and so on. The class width is the difference between consecutive lower class limits. So the class width for the data above is 10. We can get that by doing 35 minus 25, or 45 minus 35, or 55 minus 45. Warning: class width is not found by subtracting the lower class limit from the upper, which is a common mistake. In the previous example, notice that if you do that, you will get 9 for the class width. If you do 34 minus 25 or 44 minus 35, you'll get 9, but the correct class width is 10. Count it on your fingers if you don't believe that there are 10 numbers between 25 and 34. The following data represents the time between eruptions in seconds for a random sample of 45 eruptions at the Old Faithful geyser in California. Construct a frequency and relative frequency distribution of the data. And there is a geyser in California, even though the one we're familiar with is in Yellowstone, which is not in California, it's in Wyoming. The smallest data value is 672 and the largest data value is 738. We will create the classes so that the lower class limit of the first class is 670 and the class width is 10, and we will obtain the following classes. We'll have a class from 670 to 679, and again, if you don't believe that's 10 numbers, count it on your fingers. 680 to 689, 690 to 699, and so forth. It just makes things neater to start classes with multiples of 5 or 10 if that will work with your data. That's why I didn't start the class at 672. So here is our data again. And you'll notice the classes on the left. So we tally up the number of eruptions that were anywhere between 670 and 679 seconds, and we had 2. There were no eruptions that lasted from 680 to 689 seconds. There were 7 eruptions that were somewhere between 690 and 699 inclusive, and so forth. Choosing class width is something that's very subjective. There are no real hard and fast rules that say, yes, you have to do it this way. You want to choose a class width that displays interesting features of the data. You don't want too many or too few classes. Somewhere between 5 and 20 is a good target. The classes cannot overlap and they must be of equal length. So if I have a number, I have to be able to look at that number and know exactly which class it's in, so I can't have any overlapping of my class intervals. A common mistake is setting classes like 10 to 20, 20 to 30, 30 to 40, and so on, but these overlap. Which class would a data value of 20 go into? The next slide shows the Old Faithful data with a class size of 5 instead of 10. Which table do you think is better and why? Neither of these is more right than the other. One might prefer one over the other depending on what one wishes to show with the data. So here's the table with a class width of 5. Now let's look at histograms of continuous data. This is a frequency table using a class width of 10 for the eruption data. This is a relative frequency table, and notice the relative frequencies are given in percents for this graph. And this is with the eruption data again, and also with a class width of 10. This is that same data using a class width of 5, and this is the frequency graph. Here's the frequency graph using a class width of 10. And here is the frequency graph using a class width of 5. So you can see that it does make a difference, and you have to decide as the author of a study which graph shows what you want to show. Now continue to Module 2, Part 1D. The videos are broken into parts due to a short attention span and long download times.